everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about lubricants, what are the characteristics of lubricants and mechanism of lubrication. So in this we will discuss about thick film lubrication, thin film lubrication and extreme pressure lubrication. So what is the meaning of lubricant? So what purpose we are using lubricant? Generally in all types of machines, two moving surfaces rub against each other. Generally in machines, we observe that the moving surfaces rub against each other. So due to this rubbing, a resistance is offered to the movement. A resistance is offered to the movement. So this resistance is known as friction. So generally in machines, two moving surfaces rub against each other. So in this case, it resistance to offer the movement. So in this case, this resistance is called friction. This resistance is called friction. So this friction will cause a lot of wear and tear of surfaces moving parts. So generally in machines, two moving surfaces rub against each other. So in this case, the resistance is offered to the movement. So that is called friction. So when we are using this lubricant, it reduces the friction between two moving surfaces. So due to this friction, a large amount of energy is dissipated in the form of heat or in the form of friction. So due to this friction, a large amount of energy is dissipated in the form of heat. So thereby the efficiency of machine gets reduced. So in machines, two moving surfaces rub against each other. So in this case, it reduces the efficiency of machine parts. That is called friction. So how can you avoid this friction? By adding lubricant. By adding lubricant. So let's see what is the meaning of lubricant. So lubricant is a substance used in between two moving surfaces. For what purpose we are adding lubricant? To reduce the friction. So lubricant is a substance used in between two moving surfaces. So to reduce the friction is called lubricant. So now let's discuss what is the meaning of lubrication. So lubrication is a process of reducing friction and wear tear between two moving surfaces by adding lubricant in between them is called lubrication. So lubricant is a substance when we apply it in between two moving surfaces, it reduces the friction is called lubricant. Lubrication, it is a process of reducing friction and wear and tear between two moving surfaces by adding lubricant in between them is called lubrication. This process is called lubrication. Now let's discuss what are the functions of lubricant. So it prevents the direct contact between two moving surfaces. It prevents direct contact between two moving surfaces. So it reduces wear and tear between two moving surfaces and is a deformation of concerned parts. So the main function of lubricant is it prevents the direct contact between two moving surfaces. That means to avoid the friction between two moving surfaces. And second one is it reduces the wastage of energy. It reduces the wastage of energy and efficiency of the machine. It enhanced. It reduces the wastage of energy so that efficiency of machine enhanced. And next one is it reduces the frictional heat. It reduces the frictional heat and it prevents the expansion of metals. And fourth one is it acts as a cooling agent. That means it acts as a coolant by removing the frictional heat generated due to rubbing of surfaces. And it minimizes the corrosion. It minimizes the corrosion. So these are the main functions of lubricant. Main functions is it prevents the direct contact between two moving surfaces and it acts as a cooling agent. It removing the frictional heat generated due to this rubbing of surfaces. and it minimizes the corrosion. So now let's discuss what are the characteristics of good lubricant. What are the characteristics of good lubricant? Generally, lubricant is a substance when we apply in between two moving surfaces, it reduces the friction, is called lubricant. So what are the characteristics of good lubricant? So good lubricant should not undergo any decomposition. Good lubricant should not undergo any decomposition, oxidation, reduction at high temperature. So at high temperature, good lubricant should not undergo any decomposition, oxidation or reduction. And it should have high flash point and fire point than the operating temperature. So good lubricant should have high flash point and fire point. That means flash point means at which point oil gives enough vapors. That considered as flash point. It continuously burn at least 5 minutes, at least 1 second. That is called fire point. So good lubricant should have high flash point and fire point than operating temperature. So this flash point and fire point determination we will discuss clearly in the properties of lubricants. Next topic we will discuss clearly. So good lubricant should have high flash point and fire point than operating temperature. And good lubricant should not corrode the machine parts. It should not corrode the machine parts. And it should have high oiliness. It should have more oiliness nature. And viscosity index. Viscosity index means viscosity decreases at high temperature or viscosity increases at low temperature. The changes is called viscosity index. Viscosity changes depends on temperature. That is called viscosity index. So good lubricant always should have moderate viscosity index and high oiliness nature and handling point. So these are the main characteristics of good lubricant. So what is the first one? Good lubricant should not undergo any decomposition, oxidation or reduction at high temperature. And next one is good lubricant should have high flash point and fire point than operating temperature. And it should not corrode the machine parts. And good lubricant should have high oiliness, viscosity index, annealing point and high low cloud point and pore point. So these are the main characteristics of good lubricant. Now discuss most important topic is mechanism of lubrication or types of lubrication. So lubrication is the process when we apply lubricant in between two moving surfaces, it reduces the friction. So that process is called lubrication. So we'll discuss mechanism of lubrication. So here lubrication film between two contact surfaces is thick. Lubrication film between two moving surfaces or two contact surfaces is enough, thick enough, and two contact surfaces are separated completely by viscous oil film. So this lubrication film separates or avoids the direct contact of two moving surfaces. So at this time, frictional force of two contact surfaces are determined by various substances of. So this it can be determined at this time. Frictional force of two contact surfaces are determined by viscous resistance of lubricant, and it can be taken a very small value. That means the coefficient of friction can be 0.0001. So this lubrication, mechanism of lubrication. Lubrication means it is a process of when we apply lubricant in between two moving surfaces, it avoids the direct contact of two moving surfaces and reduce the friction. So there are three types of lubrications. One is thick film lubrication. It is also called as fluid film lubrication and hydrodynamic lubrication. And second one is thin film lubrication, and it is also called as boundary film lubrication. And third one is extreme pressure lubrication. So in this mechanism of lubrication, they are classified into three types of lubrication. Thick film lubrication, it is also called as fluid film lubrication and hydrodynamic lubrication. this purpose we are using lubricants are grease or Vaseline because this thickness is very high. So it avoids the direct contact between two moving surfaces and reduces the friction. So thick film lubrication, it is also called as fluid film or hydrodynamic lubrication. That purpose we are using lubricants, for example, grease or Vaseline. And second one is thin film lubrication. It is also called as boundary film lubrication. Best example is blended mineral oils. Blended mineral oils used as a lubricant in this type of thin film lubrication mechanism. And next third one is extreme pressure lubrication. So in this case we are using lubricants are oil with chlorinated esters. Oil with chlorinated esters used as a lubricant in this extreme pressure lubrication. So now let's discuss thick film or fluid film or hydrodynamic lubrication. So in this thick film lubrication, what is the main condition? Under low load and high speed. Under low load and high speed. This is the main condition. In this thick film lubrication, we apply lubricant. So in this under low load and high speed, a thick fluid film lubricant is maintained between two solid surfaces. So in this thick film lubrication, so what is the condition? Low load and high speed. So low load and high speed, in this case we can maintain a thick fluid film. Thick fluid film of lubricant is maintained between two solid surfaces. So that means that the thickness of the fluid film is at least 1000 angstroms. At least 1000 angstroms. Here, see here, what is the condition? Under low load and high speed. So under low load and high speed, the thick fluid film lubricant is maintained between two moving surfaces. Two moving surfaces. So under low load and high speed, thick fluid film lubricant is maintained between two moving surfaces. So the thickness of this lubricant is 1000 angstroms. The thickness of the fluid film is at least 1000 angstroms. So since the thick fluid film separates the two solid surfaces, it separates two solid surfaces, there is no direct contact between two solid surfaces. So it avoids the direct contact of two solid surfaces in machines. So in this way it reduces the wear and tear. That means there is no direct contact between two solid surfaces. That means it reduces the wear and tear. That means it reduces the friction. And the coefficient of friction in such cases is low, such as 0.0012 to 0.03. So in this thick film or fluid film or hydrodynamic lubrication. So what is the condition? Under low load and high speed. So in this case we can maintain lubricant that thickness is at least 1000 angstroms. At least 1000 angstroms. So in this case only it avoids the direct contact between two solid surfaces to reduce the wear and tear. That means it reduces the friction between two solid surfaces. So the coefficient friction in such cases is such low, that is 0.0012 to 0.03 coefficient friction rate. So for example, here see, consider the rotation of shaft with respect to the stationary bearing. Consider the rotation of shaft with respect to the stationary bearing. So in this case, when lubricant is added to this system, here see this image, when we applied lubricant. So here, thick film of lubricant we are maintaining here. So when we are adding this lubricant in this system, it occupies annular space. It occupies annular space between shaft and the bearing and forms a hydrodynamic wedge. That means it prevents the direct contact between two solid surfaces. You see, when we applied lubricant between, this is the shaft here, and this is the load. So when we applied lubricant in between or in this system, so when during moving, so this lubricant occupies endless space between this shaft and the load. That means it forms hydrodynamic wedge. So it avoids the direct contact of two solid surfaces. So when the load becomes very high, if in case load becomes very high, so in this case the lubricant will be squeezed. So out of the wedge and friction will occur. So always this lubricant applied, what is the condition? Under low load and high speed. If the load is high, means it is that lubricant is easily undergoes decomposition. So increase the friction rate. So that's why always we apply lubricant in what is the condition? Low load and high speed. In this case only we applied this type of thick film lubricant, and the thickness of the lubricant is at least 1000 angstroms. If in case load is very high, means the lubricant undergoes decomposition. That means it is squeezed. So out of the wedge and friction will occurs. Best example, consider the rotation of shaft with respect to the stationary bearing. So you see, this thick film lubrication, what is the condition? Under low load and high speed. So when we applied in this condition, when we applied this lubricant, thick film lubricant in between two moving solid surfaces, so it forms thick layer in between two solid surfaces. That means it avoids the two solid surfaces. The thickness of this lubricant is at least 1000 angstroms. At least 1000 angstroms. Best example is consider of rotation of shaft with respect to bearing. So for example, restive space. In this case, when we applied lubricant in the system, so during moving, during running of the machine, this lubricant occupies endless space between these two solid surfaces. So in this case, it avoids the direct contact of two solid surfaces. It is applicable only under low load and high speed only. If the load is increases, means that lubricant undergoes a decomposition. It is squeezed. So in this case, it increases the friction rate. So this is called thick film lubrication. That means in this case, it forms hydrodynamic wedge. Hydrodynamic wedge is formed. That's why this lubrication is also called as hydrodynamic lubrication. We are maintaining continuous fluid film. So that's why it is called fluid film lubrication also. And second one is thin film or boundary film lubrication. Thin film or boundary film lubrication. So in this case, what is the condition? Under high load and slow speed. What is the condition in this thin film or boundary film lubrication? High speed and high load and slow speed. Under high load and slow speed. So under these conditions, high load and slow speed, so we cannot maintain continuous fluid film. So we cannot maintain continuous fluid film in between two moving surfaces. So what is the condition in thin film lubrication? Under high load and slow speed. So this lubrication is also called as boundary film lubrication. So under this condition, we cannot maintain a continuous fluid film in between two moving surfaces. So under such conditions, the thickness of the fluid film should be less than 1000 angstroms. But thick film lubrication, we are maintaining the thickness of the lubricant is at least 1000 angstroms. But in this thin film lubrication, the thickness of the lubricant is less than 1000 angstroms. And we cannot maintain continuous fluid film in between two moving surfaces because here high load and slow speed. So the thickness of the fluid film should be less than 1000 angstroms. So such a thin film consists of 2 or 3 molecules thickness. The thickness is 2 or 3 molecules thickness. So to form thin film, the lubricant has to be absorbed on the metal surfaces by physical or chemical forces. So just now already we discussed what is the condition in this thin film lubricant. High load and slow speed. So in this case, we cannot maintain continuous fluid film because the thickness is at least below 1000 angstroms. So that means it consists of 2 or 3 molecules thickness. So to form thin film of lubricant has to be absorbed on the metal surface by physical or chemical forces. When we apply lubricant in between 2 moving surfaces, the metal surfaces is absorbed by this lubricant is absorbed by metallic surfaces by physical or chemical forces. So in some cases, the lubricant will react chemically with the metal surfaces, forming thin film of metal soap, which will act as a lubricant. So in some cases, this lubricant, when we apply in between 2 moving surfaces, it is absorbed by metal surfaces and form metallic soap film of metal soap, so which will act as a lubricant. So this thin film is known as boundary film lubrication, and it forms boundary in between 2 moving surfaces. So the coefficient friction of in such cases is around 0.05 to 0.15. This is called thin film lubrication. So what is the condition? Under high load and slow speed. So in this type of lubrication, we cannot maintain continuous fluid film in between 2 moving surfaces. And the thickness of this lubricant is less than 1000 angstroms. That means it is a 2 or 3 molecules thickness. So in this case, when we applied this type of lubricant in this type of mechanism in between 2 moving surfaces, here the lubricant is absorbed by metallic surfaces by physically or chemically. And sometimes it is absorbed by metallic surfaces, then form a metallic soap film. Metallic soap film, that means it forms a boundary layer in between 2 moving surfaces. So, and the coefficient friction in such cases is around 0.05 to 0.15. For example, here see, these 2 are moving surfaces. So, when we apply lubricant in between these 2 moving surfaces, it is absorbed by physically or chemically by the metallic surfaces, or it forms a metallic soap. Metal soap is formed in between 2 moving surfaces or solid surfaces. So in this case, it acts as a metallic soap film. So in this way, it avoids the direct contact between 2 moving surfaces and reduces the friction. And here in this boundary film lubrication, the effectiveness of boundary film lubrication depends on oilness of the lubricant. The effectiveness of the boundary film lubricants depends on the oilness of the lubricant. So in this thin film lubrication or boundary film lubrication, the effectiveness depends on oilness of the lubricant. So oilness is the ability of a lubricant to stick on to the surface. So for example, in this purpose, we are using vegetable oil and their fatty acids, because these oils are having more oilness nature. So in this thin film lubrication, the effectiveness is mainly depends on oilness of the lubricant. So which type of oils are having more oilness nature? Vegetable oils and their fatty acids. Generally, these vegetable oils and their fatty acids used for this purpose, because the effectiveness is mainly depends on oilness of the lubricants. For example, we are using here oleic acid. Its molecular formula is C17H33COOH, and stearic acid C17H35COOH. So here the polar groups of carbonyl, that means polar group COOH of these oils are react with metal surface to form a continuous thin film of lubricant. And hydrocarbon chain of these fatty acids gets oriented outwards the perpendicular direction. For example, see here, effectiveness of this thin film lubrication depends on oilness of the lubricant. So that purpose we are using which type of oils? Vegetable oils and their fatty acids. For example, oleic acid or stearic acid were used for this purpose. So when we applied these oils in between two moving surfaces through solid surfaces. So in this case, the polar groups, that means head part, that carbonyl groups of these oils reacts with metallic surface. Directly reacts with metallic surface to form continuous thin film of lubricant. This is the continuous thin film of lubricant. And the tail indicates here, heads indicates the polar group COOH and this tail indicates hydrocarbon chain. Hydrocarbon chains. So this is the polar groups are head and this has C78, that is hydrocarbon chains. So this hydrocarbon chain of the fatty acids gets oriented outwards in a perpendicular direction. You see this image clearly shows that when we applied in between two moving surfaces, so it is directly chemically or physically absorbed by metal surfaces and it formed metallic soap film in between two moving surfaces. That means boundary film formed in between two solid surfaces to avoid the friction. So polar groups directly absorbed by metallic surfaces and hydrocarbon chain. They are arranged in oriented outwards in a perpendicular direction. So in this way it avoids the friction between two moving surfaces. That means it forms boundary layer in between two moving surfaces. That's why this lubrication is called boundary film lubrication. And most important point is the effectiveness of this boundary film lubrication depends on oilness of the lubricant. So that purpose we are using vegetable oils and the fatty acids used because they are having more oilness. So last type of mechanism is extreme pressure lubrication. Extreme pressure lubrication. So what is the condition here under high load and high speed? What is the condition under high load and high speed? But in thick film lubrication, low load, high load and low speed. In thin film lubrication and thick film lubrication, high load and slow speed. And extreme pressure lubrication, high load and high speed. So under the condition of high load and high speed, high load means here generally observed high pressure and high speed. So in this case, more heat is generated in between two moving surfaces. Generally observed in machine parts, two moving surfaces. In this case, high load and high speed, generally it produces more heat generated in between two moving surfaces. So as a result of this, the liquid lubricant fails to stick and undergoes decomposition and evaporation. So that means we cannot use normal liquid lubricant because it is undergoes decomposition or undergoes evaporation. So under these conditions, for effectiveness of lubrication, special additives we are adding. So normal lubricant, if we are using this purpose, in this case it undergoes decomposition. That means it is fails. So it undergoes decomposition or evaporation. So under these conditions, for effectiveness lubrication, special additives are added that is known as extreme pressure additive. That is called extreme pressure additives are added used along with the lubricant. So example here, important extreme pressure additives are organic compounds which are having active radicals or groups such as chlorine. For example, sulfurized oils used for this purpose. And these compounds react with metallic surfaces to form metallic chlorides or metallic sulfides. So these metallic compounds composes high melting points. So serve as a good lubricant under extreme pressure conditions. So here, lubricant is a substance when we apply in between two moving surfaces, it reduces the friction. So that is called lubricant, and that process is called lubrication. So there are three types of lubrication. One is a thick film lubrication, and second one is thin film lubrication, and third one is extreme pressure lubrication. So in this thick film lubrication, what is the condition? Under low load and high speed. If in this case we are using normal lubricant, if thickness is low means it is easily undergoes friction. That means it increases the friction rate. So in this case, the thickness of the lubricant is at least 1000 angstroms. So in thick film lubrication, what is the condition? Under low load and high speed, and the thickness of the lubricant is at least 1000 angstroms. If in case load is high means it is easily undergoes decomposition. So in this case, we cannot use this type of lubricant. So thin film lubrication, it is also called as boundary film lubrication, and what is the condition? Under high load and slow speed. So in this case, we cannot maintain continuous fluid film, and the thickness is below 1000 angstroms. And extreme pressure lubrication under high load and high speed. Generally, in this case, we cannot use normal lubricant because it would be generated more heat. So if we are using normal lubricant, it undergoes decomposition or it evaporates. It fails to stick onto the surface. So that's why they are using, under this condition, effective lubrication purpose, we are adding some special additives such are known as extreme pressure additives. Extreme pressure additives. So in this purpose, we are using some extreme pressure additives are organic compounds such as having active radicals or groups such as chlorine, sulfurized oils, etc. So these compounds react with metallic surfaces to form metallic chlorides or metallic surfaces, etc. So extra additives also added along with lubricant. So in this case, there acts as a good lubricant under extreme pressure lubrication. So we are adding extra additives along with lubricant in this extreme pressure lubrication, because if we are using normal lubricant, it is easily undergoes decomposition. So this is extreme pressure lubrication, and the condition is under high load and high speed. So that purpose we are using some extra additives along with lubricant. So in this session we'll learn about what is lubricant, what is the mechanism of lubricant, which type of oils are suitable mechanism purpose, that thickness, for example, thick film lubrication, we are maintaining one layer of lubricant, that means grease or Vaseline. Which viscosity is more, the type of lubricant is we preferred in this thick film lubrication. And thin film lubrication, it is directly absorbed by metallic surfaces. We cannot maintain continuous fluid film. So in this thin film lubrication, it is effective in its purpose. Lubricant is used more oiliness of the lubricant. For example, blended oils, vegetable oils and their fatty acids, we are maintaining in that thin film lubrication. And extreme pressure lubrication, we cannot use normal lubricants because what is the condition? Extreme pressure lubrication under high load and high speed. So in this case, it generates more heat. So that's why we are using lubricant, more oiliness lubricant, and also we are adding additives. So additives are added along with lubricant. So in this class, we discussed about types of lubrication and which oils are suitable for that lubrication purpose. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.